So let's take a look at another situation where perhaps we have an exponential function, but there's not one exponential. Maybe there's two. One on each side of the equation. And for some of these examples, I think they might be a little easier than what we can anticipate. 3 to the x and 3 to the fourth. They're equal. I wonder what x could be. If the bases are exactly the same and the numbers are equal, I bet their exponents have to be the same. I'm guessing x here is equal to 4. The only way 3 to the x could be equal to 3 to the 4 is if x equals 4. Or maybe x equals pi, or even 1.46. You see, if the bases are the same, this is an easy game. Just set those exponents equal. Here's our examples for reals, yo. Because what if those bases aren't exactly the same? What if they're close to being the same? So for example, over here I have 4 and 8. What I need to do is come up with a base that will be the same for both 4 and 8. I don't need to be thinking about, factors, multiplying things together here. I need to be thinking about what powers. Power of what equals 4? I think I can say 4 is the same as 2 squared and 8 is the same as 2 cubed. Well, now, that's useful because now I have an exponential on each side with the exact same base. All I need to do is use some exponent rules to simplify those powers. And when I take one power to a higher power, when I say higher power, I don't mean God, I mean math. When you go from one power to the other, you multiply. So what is 2 times 3x minus 1? 2 times 3x minus 1. And then I have 3 times x plus 1. Now this is looking a little better. We have the exact same base. One has a little circle, one doesn't. I don't know why, but there's still the number 2. And if they both have equal bases, I bet their exponents must be the same. Now you can solve this problem like any other algebra problem. I'll subtract 3x from each side, and I'll add 2. I'll probably even divide both side by 3 just because it's really convenient at this point, and I'll have a lovely answer there, x is equal to 1. So I want you to take a look at this next example 6. This is still in the notes on the portal. Please look at the notes for Chapter 4, Lesson 5, Solving Log and Exponential Functions. Okay? This is example 6. What base could I write that would be common for both 3 and 1/9? Well, 3 to what power equals 1/9? This should pretty much be the same. That's 3. This is 3 to the negative 2nd. What I mean by that is, all I'm doing is I'm rewriting the 1/9 to make it 3 to the negative 2nd. Now, both of them have a common base. If I could just simply rewrite this, combining this power of a power, I multiply them together, well now this should be easy. If they both have the same base, I bet their exponents are both going to be the same. How about that, ladies and gentlemen? It looks like we have a couple more solutions.